Well, I finished the whole chapter 3 last time, so I don't have any more to do this time, so I'm just going to go into demonstrating the projects, which is fine, because I like to cover the SQL injection, which students often have difficulty with, and then get you into the Web Security Academy, which is where you should spend most of your work this semester. Most of your time should be spent inside this thing. So let's just get to that. So ED 103 is the SQL injection project. And this, now, let me just review what we did last time. We did command injection in Bash. So you have this ping form where you can put in an IP address, and after the IP address, you can put a semicolon, and then you can execute a Bash command like ls, which lists all the files, and you can do things like who am I, and you can do things like IPA. Now that might not work because of the problem with the space, but anyway, so it did who am I, which is www.data. It did an IP, told you about the IP address. So you can execute commands. So this is pretty easy to understand, but you do have to understand this language of Bash commands. You have to know how the commands work in order to accomplish things here. And SQL injection is exactly the same, but the reason it seems harder is because you have to learn this language called SQL, which is a less familiar language. So first, I'm just going to reset the server with a script here that mostly undoes the damage students do to it. And here's what SQL does in the simplest case. What a database administrator has access to a place where they can put in any query they want. And so they can do queries like this, show databases. And databases are software containers of data. And there's one called information schema that is automatically created by the database software itself, MySQL. And the second one is one created for company data. So let me close that door because they're always noisy. So there's two databases. The first one, information schema, is automatically created and it always has the same name. So it's real important to us. That's where we can look to see the structure of the database. The second one is what's going to contain company data like social security numbers and other valuable things. So we can show the tables. Now the tables, if I didn't specify what database they're in, it'll be in whatever this query regards as the current database, and it turns out that's in widgets. So the widgets database contains one table called employees, and all right, so we'll play with that a little later, but let's talk about other things you can select. You can select picks data out of the databases, but you can also just echo information that did not come from a database. I can select one, and the answer is just one. So that might seem useless, but that's going to be helpful. I can also select text, and I can also even concatenate together pieces of text. So I can take peanut and butter and add them together and get peanut butter. So we'll be using that a little later. And I can also pick pieces of a text out. So here I'm going to select the second character and the third character in the word peanut. So I go substring peanut starting at character 2 and going on for 2 characters, and for some ungodly reason it starts counting at 1 just to drive you insane. Usually computers start counting at 0, but every now and then we do it differently just to make it as confusing as possible. So SQL starts at 1, so this is the E and the A out of peanut. And now this is where you can also do a logical comparison. So here we're going to select the substring of 2, 1, which is the E. Does the E equal A? And the answer, of course, is false. And so you get 0, which is what it has for false. Now, if I make it something that's true, that it equals E, then I'm going to get a 1. So 1 is true and 0 is false. All right. And so that's now you remember back up here when I showed tables, I found, you have to know the name of the database that contains the data you want, you have to know the name of the table that contains the data you want, and you have to know the name of the fields in that table. There's 3 layers of information. And you can get anything you want, but you have to ask for it by name. So that's why these commands are important to find out what's there. There's a table called employees in the database called widgets. So I can select star from employees, and that will give me everything in the employees table. So you get ID, name, and social security number for each of the people in the database. So this is handy. The problem is that Usually, as you'll see, selecting star is not practical. What you have to do is select something individual. So I can select, say, ID for employees, and then I'll get the IDs, but nothing else. Or I could select ID, and I could put comma, name. That would be handier. Then I'm going to get 2 columns, ID and name for each person. Or I can mix a data from the database with fixed database, so I could do ID, comma 2, and then I'll get an ID and then always a 2. So these are things you can do. And so here's so now I could do this. I could add a from clause, which will get just one record. So instead of getting all the data in the database, I'll just get the one for ID equals 1. So where this condition is true, and that's the first person in a database, I get their name and ID. So, all right. Now, if I wanted to put that in a single column, I could take name, comma, ID and concatenate it, name, ID. And then I will get one column containing both pieces of information, name, Bill Gates 1, the name followed by the ID. And I could have more complicated where conditions. I could have ID equals 1 or cat equals dog or 2 equals 2. You can make as complicated a condition as you like. So ID equals 1 is true for the first record, but no other records. Cat equals dog is never true, but 2 equals 2 is always true. So this compound condition, ID equals 1 or cat equals dog or 2 equals 2, is always true. So now I will get all the data in the database, every record. I'll get what I asked for about every record. And this is going to be important to us later. You can also insert data into the database, although that's not important for what we're doing here. So now we found that there's all right, so if you wanted to find, you can get table names from information schema tables. This will show you the tables in the databases. And it'll show you by default the tables in the current database. Now this is the information schema tables. I asked for information schema, and so I'm getting all the automatically generated tables, and they all have these strange capital names. And there are hundreds of them, or a lot of them. And then at the end, you see employees. That's the one in widgets. So the information schema tables has all the tables that exist in all the databases. So the capital ones, the automatically generated ones, the one at the bottom, traditionally in lowercase, is the one created by the company to have company data. Now I can get columns. So if I do this, I'll get all the columns there are, and those are all the fields in all the tables. And that'll be, of course, a much longer list, all these automatically generated things. And at the bottom, I thought I would get them from the widgets database too, but I don't see it. Anyway, the point is that will kind of drive you crazy. What's a lot better is to do it this way. Select column name from information schema columns where table name equals employees. Now you'll get the columns for just one table, which is more likely to be zeroing on the information you need. And you'll see the table employees has 3 columns, ID, name, and SSN. So this is how you learn the names of the columns, tables, and databases you want to steal data from, and then you can ask for that data. Now, the problem is, normal users do not have access to this box. You only let a database administrator have access to this box. With this box, they can read any data, they can alter data, and that's crazy. You can't let a customer have that kind of access. What customers get is something like this. They get a name search field, like if you're on Facebook or Twitter or something, you can search for users by name to see if they're there. So I can search for Bob. And when I search, it's going to not find anything because there's nobody named Bob in the database. And by the way, each one of these, the solid bars, denote a region with a different database. So I'm going to reset the server here. All right. So, however, there is somebody named Bill Gates in the database. If I search for that, it returns Bill Gates. So it found that person. All right. But now, if I put in a name with an apostrophe, like Tip O'Neill, and I got extra junk here, but it doesn't really matter, then I get an error. Now, this is really bad. Nothing you put in should ever create a syntax error. It should just be data from the user. It should either find it or not find it. If there's a syntax error, that means the code can't run. And that means part of the data I put in is interpreted as a command. And you can see the line here. The developer wrote this: select name from employees where name equals apostrophe. Then this is the data that came from the user. and the developer putting the apostrophe at the end. So I only control that. The problem is this is parsed to match apostrophes. The apostrophe from the developer matches this apostrophe from the user, ending the string, and now it expects a command here, something like and or, and it found Neil. That was the error. This is the problem with SQL injection, and it's just like what we had in the ping form with bash command injection. By inserting a special character, in this case an apostrophe, I can follow it by a command that will execute, if I figure out how to write a proper SQL command there. So you have to do something like this. Now, I get everybody because I fed in this name, Sam Sam apostrophe, or 1 equals 1 pound. And what that did was the apostrophe from the user, matched this apostrophe from the developer, and changed the name into Sam. And there's nobody named Sam. So this condition will never be true. But then I put in or 1 equals 1, which is always true. And then I put in a comment character to eat up that remaining apostrophe so it doesn't crash for having the wrong number of apostrophes. So I created a combined condition here, which is always true. And that's why I got all the data. And so that's why you have a lot of these now. So now I can dump data, but one thing notice, the only thing I can get is the names. I didn't get the social security numbers because the developer wrote this part and I can't change it. So the only thing I'm getting is names. So this would seem like it's not very powerful, but it's more powerful than you think because you can do a union. A union lets you add two select queries together. So if I do this, Sam union select 1, with the right punctuation marks, which are essential, then it's going to run the query that the developer intended, looking for name equals Sam, and have no results because there's nobody named Sam. Then it's going to add select 1. So I get a 1. Now notice, the developer only asked for one thing, one column. So I can only add another table that has one column there. If I try to add 2 columns, like 1, 2 here, I'm going to get an error saying the use select statements have a different number of columns, which is why I say if you wanted to ask for 2 things, you'd have to concatenate them together into one field. Anyway, so the point is now, what I've done is I can now have select query here. So I've turned this box into this box. I can do any select query I want by replacing the select 1 with anything I saw up here. So if I want to see, for example, all the tables in the database, I can take this one, select table name from information schema tables, and I can put it here instead of select 1. And that's why you get these long, confusing looking things. It takes a little practice to handle these SQL injection, but if it works, there you are. Those are all the table names, and notice at the end are the couple that I care about. There's a table named employees and a table named passwords. So now I like the data from those tables, but I have to know the field names. So I'll go up and get this one, where I get column names from information schema column where table name equals employees. And I know there's one table named employees and one table named passwords. So I'll do them one at a time. Here's the employees. This whole mess here, I might be able to make it bigger. Yeah, I think I can. There we go. That whole mesh now will take all the columns where table name equal employees and let me see them. So the employees table has ID, name, and SSN. So that's useful. And if I want to know the passwords table has ID and password. So I can now get the information from them. So I could select ID from select ID, I think from passwords. I don't think I need I think I can just do that. Let's try that. Select ID from passwords. Yep, I get it. Now I know there's a field called PW in there. I could do that, but I don't know how these match up with the IDs. And if I try to get both the ID and the password, I get a problem. So what should I do? You guys out there, what do you do?
Use the AI.
Use the AI? Well, if as a matter of fact, you could ask that question of an AI and you might get a good answer, but do any of you know what I do now? How do I get around this problem? How do I get the ID and the password?
Do like an OR or something? Like concatenating?
Concatenate, that's it. You have to put them in one column. So I should be able to concat these two things to make one column out of these two fields. And that works. Now I get the name and the password. And by the way, they kind of all ram together. If you want, you could be kind of classy and put in a space. And then you get a nicer printout. But so now I can get the ID that matches the password, and then the other table I can get ID and match it to name, and then I can figure out which password goes with which name. So that's what you can do. And like I say, it takes a little while to get used to it. But to understand what's going on, you go to the place that you know exists, which is this information schema. This thing always exists. And then in there you get the names of the tables and the columns you want. And then you ask for the columns out of the tables. But you need to find the names of the tables and columns. Of course, sometimes you can just guess them. They have nice obvious names like SSN or password, but sometimes you can't guess, and you can always get them with these queries here. So that's the issue, and now you can answer a lot of flags. You can find people's social security numbers and passwords. Now, the real pros, pen testers, don't do it by hand. They do it with SQL Map. SQL Map is a Python script. It's built into Kali. You can easily install it in any Linux distribution, and it automatically sends hundreds of queries to the server and dumps out the data. It can detect vulnerabilities, and it can exploit them. And if you want an example, I have a project I wrote years ago that just shows you the general process here. We're not going to use this SQLOL, that's an old product, but it shows you what you're doing. First you determine vulnerability, you just do -u and give it a URL going to the database, to the SQL database with a parameter, and it will find out if any of those parameters are vulnerable. So it found out that it's vulnerable. Then to find the databases, you use current user, current DB is DBA, users DBS. These are things. You can do a help page and see them all, but this will dump out the current user. This will dump out the tables. This will dump out the columns in the table you choose, like SSN, and then you can just dump all the data here. So there's a lot of, this is what the pros use. They use SQL Map, and it automatically does all this for you. Now, one reason why you'd really want to use SQL Map, and I see OS27 also had concat, which is the right answer before, is not all the cases are as easy as this. Now, what we did was we attacked something where the result of this query is really to show you some data from the database. So if I search for somebody who isn't in the database, it returns data from the database. So that's handy. It really does select name, and then it displays name on the screen. This is normally the case, but sometimes that's not true. That uses data, but it doesn't present any data back to you, and that's when you have blind SQL injection. So here, if I search for Bill Gates this time, or first I'll reset the server. All right. If I search for Bill Gates, I find Bill Gates. So that looks pretty good. It looks just like the last one, but it isn't, because if I do this one, X or A equals A, then I get a very strange answer. Now, what I put in was X apostrophe or apostrophe A apostrophe equals apostrophe A. And if you include the apostrophes on the outside that the developer put in, this is now a valid statement. Name equals X, which is always false, or A equals A, which is always true. So it dumps all the names from the database. But I don't see any of them, because the way this query works is you never see the data from the database. If it's true, it echoes back the name you put in. If it's false, you get no response. So so if I go back and change this to A equals B, which is false, then I get no reply. So you cannot dump any data from the database, but you can answer a true or false question. You can get one bit of data. You can put a query here that's either true or false, and it will tell you whether it's true or false. It'll echo back your input if it's true, and you'll get nothing if it's false. Therefore, you're playing 20 questions. You're asking yes or no questions and narrowing things down. So if I want to know the length of the database's name, for example, I could put in this one to see if the length of the database is 1. And it's false. The length is not equal to 1 because I got no result. Well, I would think that probably means the length is probably greater than 1, so I can put a greater than there, and that's true. So now I could try different values until I find the length of the database, and I can pump out social security numbers and IDs and passwords and everything, because remember way back here, I can pick one letter. So let's take an example, and I think I've got it down. Yeah, here we go. Yeah, this one. So let's start with this one. This is showing how you pump out an alphabetic thing this way. All right, so now I'm going to select name from employees where name equals Bill Gates and substring name1 equals B. And that is true, so I get a reply where it echoes back all my stuff. So the first letter in Bill Gates is really a B. If I made this A here, then I would get no reply. So you might think it would take you 26 guesses or even more to find a letter, but not really, because you could do this. Let's take the second letter, which is a lowercase I, and see if that's equal to A, and of course it's not. But the lowercase, but it's therefore greater than A, and it's or in ASCII order. So the lowercase letters are above the uppercase letters. So this is true, and it should also be greater than capital Z. And, oh, it's not. Okay, so maybe SQL is case insensitive. So it's I, so I guess that's greater than D. And it is. So, you can use greater than and less than to cut the graph in half. It won't take as many queries as you think to zero down on something. You get one letter. Then you have to get the next letter and the next letter. So it does take dozens of queries, but you can learn anything you want this way. And that's why people love that automated tool, SQL Map, that will really make the hundreds of queries to pump it out. And by the way, sometimes the difference between the true and the false statement is more subtle than this. This time, when it's true, it gives you output. When it's false, you get no output. Sometimes what happens is when it's true, it takes a longer time to process than when it's false. So you have to time it, that kind of thing. But those are all called blind SQL injections when there's some clue you can find in the response that tells you whether your query is true or not. And I hear a question about the pound, and let me explain that. Let's go back to this simpler one here. All right, let's leave it at this one. That's fine. The purpose of the pound is to eat up this apostrophe at the end with a comment character. That's all. Otherwise, I would have to not put in the apostrophe myself that I put in. That's all. The purpose of the pound is to end the string. So there's two ways to do this. One way is to put in the full statement greater than D and put a pound in. The other thing is to remove the pound and that apostrophe, so the apostrophe from the developer will fill it in. That'll work too. So you can do SQL injection either way. And by the way, when I do this, there are several different databases, and some of them pound is not the comment character. So when I'm doing capture the flag contests, I try pound and dash dash and slash slash and a few to find what the comment character is. And so anyway, and when you're doing this kind of work, it's really important, like in any kind of pen testing, always have a notepad file and always keep notes of what you do, but especially when doing SQL injection, because you end up having these long, horrible things like this, and it's very easy to make a mistake. So I make one, I try it. Every time anything works, I save that, because very often I fall off the track and get lost and have to go back to the one that worked and make small changes. So you have to keep good notes. Also, you have to keep notes of what you find. You're going to find the table names, then you're going to work to find the column names, then you're going to have forgotten the table names. So keep notes as you dig in here. Anyway, it's good for you, and you can make a ton of extra credit here. I only thought 30 points of this were enough to require. There's 155 points more if you keep doing these. So check them out. And that's what I wanted to show you. I'm going to stop this recording.